In the next couple of videos, we'll talk about problem number 4. A tank contains 125 gallons of heating oil at time t equals 0. And during the time interval for t equals 0 to 12 inclusive, the heating oil is pumped into the tank at the rate of h of t equals, etc. During the same time interval, heating oil is removed from the tank at the rate r of t equals so many gallons per hour. A. How many gallons of heating oil are pumped into the tank during the time interval from 0 to 12 hours? Since h of t gives us the rate at which oil is being pumped into the tank, then the area under that h of t curve will give us the amount of oil that is being pumped into the tank from 0 to 12 hours. And so all we need to do for this is to use the calculator to evaluate that integral. And I will call up the calculator and go into y equals. And there I put in the two functions that we're going to be using here, along with a difference of them. And I'll explain the meaning of that third function in just a bit. So y1 is h of t, and y2 is r of t. So all I need to do for this is to take the integral of y1 from 0 to 12. And to do this, I'm not going to set up the graph right now. I'm going to go back out, math, up arrow, going down to fnint, vars, yvars, function, y1, comma, x is my variable of integration from 0 to 12, and that gives me 70.571. And that's the amount of oil that has been pumped into the tank over the 12 hours. Now, oil is also leaving the tank, and there was some oil in the tank when we began, so that's not the amount of oil that's in the tank at the end of 12 hours, but it's the total amount that has been pumped in over that time. Let's go on to B. Now B says, is the level of heating oil in the tank rising or falling at the time t equals 6 hours? Give a reason for your answer. Well, the level will be increasing if the rate at which oil is being added to the tank is more than the rate at which oil is leaving the tank. And we can say that level increases when h of t is greater than r of t. We can also say that when h of t minus r of t is positive, then the level will be increasing. So if we're looking for at time t equals 6, what we need to do is to evaluate h of 6, subtract from that r of 6. And again, we'll bring in the calculator to do this. Now h of 6 is y1, so we can simply do variables, y variables, function y1 of 6 minus vars, y vars, function y2 of 6. So that's h of 6 minus r of 6. And we're told that that equals negative 2.924. And since that number is negative, it means that in fact that r of 6 is greater than h of 6. The amount of oil leaving the tank is more than the amount of oil being added to the tank, and therefore the level will be decreasing. We'll get the calculator out of the way. And we say that since this is true, the level is falling. Therefore, the level is falling. Now for part C, we want to find out how many gallons of heating oil are in the tank at time t equals 12 hours. Well, we know how much has been added to the tank. That's integral from 0 to 12 of h of t. The amount that has left the tank would be integral from 0 to 12 of r of t. And plus we had 125 gallons to start with. So we have 125 plus integral from 0 to 12 of h of t dt. That's the amount of oil that's been added, minus the integral from 0 to 12 of r of t. That's the total amount of oil that has been removed from the tank. So we'll bring in the calculator. And 125 plus 70.571 is 195.571. And we add to that the integral of r of t, which is in y2, from 0 to 12. And we get 269.116. Sorry, we should subtract that. And that's our answer.